Yeah, camps on everyone. Let's start off. So let's say we got a cube here. Eta is your rigidity modulus. Hope you guys remember what is rigidity modulus. Rigidity modulus eta is your force parallel to the surface by area delta x by t. So whenever you take a body there and when you apply force, let's say the bottom is fixed. So this F is the force acting parallel to the surface. This delta x is the relative displacement between two layers and d is the distance between the two layers. So that's your shearing strain and shearing stress. Now what happened? You took this block and you started applying force. Remember, the bottom is not fixed. It is smooth here. This block will start moving and the surface actually starts bending. It's not exactly a full curve, but I'm exaggerating the figure there. Did you guys ever drag a rice bag in the kitchen? Let's say there is a 25 kg rice bag. If you try to drag the rice bag, so initially the rice bag will be like this. If you catch one corner and pull the rice bag, won't the rice bag become something like this? So the shape actually bends. So find the equation of this curve. If the cube was fixed, you would have got a straight line. But if it is free to move, you'll get a curve. Find the equation of the curve. For the Friday class, right, make sure to go through the AC circuit ka notes. People who are new should definitely go through the recording because if you remember, I taught you with something called phasors. Yeah, the complex numbers ke sath we did it. So it was completely something different. It is not the standard thing that we did. So please spend some time. It will take half an hour. So just go through the AC notes ka recording. I'll post the link again in the group if you want. Just go through that part. It's very important. We have, just to give an idea there, we did it in a pretty different way. We have converted resistances and everything into complex numbers basically. So we have converted an inductor into a complex resistance, I omega L, I ka place mein J we will write. Capacitor has become something like this. And it's a pretty easy one, but we did it in a different way. So please make sure to go through that. If you see all vector forms. So please make sure to go through that for the Friday class. Friday, Monday, we'll be doing EMI AC, quite an important topics. Mostly Monday, we'll not be having an exam because I think mains ke liye people are already getting busy preparation. So maybe next Monday, I'll just give a paper to write at home in case you want to do it. Dates आ गया सबका? They didn't give the center na yet. That is yet to come. Who got earliest first day? Anyone got second? 1, 2, 3, 4. Okay, there are 4 people. Who got the last day? Okay, Shaunak got it. ठीक है, either way. Second Aditya. Okay. How do you do this thing? First day. No, in a way, it's a good thing. अगर first day जल्दी हो गया, then yeah, you can focus on bits then. Yeah, if you're planning to improve mains, then yeah, second or third day would be nice. But how do we handle this? So the main idea here is as you go down the cube, right, the tension will not remain same. When you apply force F, this is the acceleration, which is F by m. So if you go at a depth y from the bottom, at this point, the tension at this point is because of the bottom part. So tension will be mass by length into y into acceleration. So tension will be Fy by L. So that means as the y becomes smaller, tension becomes smaller. Making sense? So every section of this thing will have different tension. You're getting why? Because think about it. This part of the body has to pull only this much shaded mass. If you go higher, then you have to pull this much mass. So as you go higher, you have to pull more and more mass with the same acceleration. So the tension will keep changing. So here somewhere you take a small section here. This will be dy and this will be dx. So when you apply rigidity modulus for this thin strip, that will be the tension in the strip by area, which is L square. And what is this thing? Delta x by d. What is delta x by d? The displacement, relative displacement between two layers, in this case that is dx, by distance between the two layers, that is your dy. So here the shearing strain is dx by dy. The horizontal displacement is dx and the distance between them is dy. You're done basically. So this would be tension would be Fy by L cube dx and dy. Integrate on both sides. You end up with eta L cube x is equal to F into y square by 2. You get a parabola. So that thing which you get, the edge is actually a parabola. Clear with that? So you can play around like this. Another way to do the same question is like this. What if you have the density rho is equal to rho naught y? Matlab, this block cut density is also changing with height. Then your tension will change with the function of y square or something. Then you'll not get a parabola. You'll get some other function. So you can play like that. Or else you can even mess up the rigidity modulus. Rigidity modulus will be eta naught into 1 plus y by L. You're getting the idea there? So there are multiple ways you can mess it up. So I gave you the idea there. So they can mess up that eta, they can mess up the density. So it won't be so straightforward there. Clear with this? Now, rigidity modulus, right, is one thing where I have not seen, much of a questions on that. So it's one good model there. Let's see this one. This we did in the class notes. They can frame really good questions on this. So we have a fixed cylinder. The radius is r, length is L, and rigidity modulus is eta. So if I take this as point O and this is point A, now what you did, you started twisting the cylinder. You're getting? You're twisting the cylinder. So when you twist the cylinder, this is what would happen. This would be O, this would be A. So basically you twisted this thing by an angle theta. So find the torque required to twist the cylinder by angle theta. So this torque is called torsional torque. The angle is called torsional angle. You must have heard this word, yeah, the torsional pendulum. Find the torque to required to twist the cylinder by theta. And find time period for small oscillations. So if you twist it by small angle and leave it, this thing will actually oscillate. That becomes a torsional pendulum. Now, instead of a solid cylinder, what if you make a cylinder with a cavity? R1 and R2. So instead of solid, if we make a cylinder with a cavity of same mass, okay, if you have same mass, then which is more difficult to twist? R1, R2 are not given. You can even play with that. Find the ratio of R1 by R2 for maximum torque required to twist of same mass, which is more difficult to twist, a solid cylinder or a cylinder with cavity. And you can play around a lot. First, let's get the first part, the torque part. So the moment you hear the words twisting and everything, these all are based on shearing stress. But how do you prove that mathematically, Vihan? You can even do that. For a given mass, find the ratio of R1 by R2 or find the relation between R1 and R2 for maximum torque or maximum torsional constant. हाँ ये क्लास नोट्स में क्वेश्चन सब फीलिंग है रे your answer might be right but exam में will you have the guts to mark the answer. See, you need to understand something. In the class, when you're telling the answer, ask yourself, if this was the actual exam, will I have guts to mark the answer? Then it is fine. Then I think then you're fine with your logic. Because in the class, na, it is very comfortable, relaxed. Even if you say wrong, nothing happens. Exam में ऐसा नहीं होता है. Even 2 plus 2 will start giving a doubt. Is it 4 or 5? किया ना, last year your senior. He did 12 minus 8, he wrote 20 and came for the integer question. क्या करना था? See. So take a thin ring at a distance x. You are comparing this with a ring on the floor. So when you say that dx by dt, you are comparing the upper ring with this ring, isn't it? So this ring will move how much? This ring will move a distance of x theta, isn't it? So every ring will have a different displacement. So the force on the ring, so this is the tangential force on the ring, will be eta. Area will be 2 pi x dx. Delta x is the displacement between the two layers, which is x theta, by distance between the layers L. Isn't it? That ring on the topmost thing, circle, that will rotate by x theta, whereas the ring on the floor is not rotating, that is at rest. So the relative displacement is x theta. Are you sure with this? And then this is the force on the ring. So what is the torque on the ring? The torque on the ring will be x into this guy, F on the ring, tangential. So that would be 2 pi eta theta x cube dx by L. So the total torque on the cylinder will be pi eta r power 4 by 2L into theta. This value here is called K. This is called torsional constant. So this tells you how difficult it is to twist a cylinder. So if you see the torsional constant here, it is pi eta r power 4 by 2L. So this is proportional to r power 4 by L. Means if you take a cylinder of radius r and 2r, the 2r cylinder is 16 times more difficult to twist. So if you see babies, right, who is like 3 month or 4 month old, if you see they have very tiny hands, so you have to be very careful. You can't just, catch. That is the thing, you have to be very careful with the kids. If you have a kid who is 5 year old, and if you take a kid who is 5 months old, the hand ka diameter ka difference will be like 1/3. That means 81 times they'll experience more stress for the same amount of twisting. But luckily, kids, right, are more fluid in nature. they have more bones than an adult human being. They're very flexible. They're like, you can just compress them and all. So kind of the human babies are designed in such a way to be careful. You never seen them? I have seen them. My nephew, when he was there, right? That the lady who used to come to do massage to the baby literally used to take the legs and the head and fold it like a spring. And I was like, what the hell are you doing to the kid? But yeah, the kids are more boned, so it works for them. I think evolution made sure to do it. Anyway, so that is the thing. But what if it is a cavity thing? अभी time period के लिए क्या करेंगे? Question हो गया ना? For time period के लिए we'll do torque is equal to minus k theta. K is this guy. So this will be I alpha is equal to minus k theta. Alpha is equal to minus k by I theta. So the time period will be 2 by root over I by k. Again SHM का question. So if you twist it by small theta and leave it, it is what will happen. Suppose if this was a cavity, then क्या change होगा? Limits will change ना? Instead of 0 to r, limits will be from r1 to r2. So in this case, the torque will be pi eta. This will be r2 power 4 by r1 power 4 by 2l theta. That would be the value there. Now mass is same, right? Density, the first one will be pi r square l. This would be rho pi r2 square minus r1 square by l. So we have this relation r square is equal to r2 square minus r1 square. Now if you're trying to compare the constant there, so k1, so if you try to compare r square is to this thing r2 square minus r2 power 4 by r2 minus r1 power 4, which one will be bigger? We can cancel one r2 square. One r square, one r, this one will cancel, agreed? Then you get r square is equal to, I'm just trying to find the ratio there. So how do I find which one is bigger? So the first thing, if I take the proportionality constant k1 by k2, that would be r power 4 by r1 power 4 by r2 power 4. This can be written as r square r square. R1 square plus r2 square by r1 square minus r2 square. This guy will go off, and then you end up with r2 square minus r1 square by r2 square plus r1 square. This is 1 minus r1 square r2 square by 1 plus r1 square by r2 square. So this thing is definitely less than 1, isn't it? So k1 is less than k2. So k2 is greater than k1. That means keeping a cavity in the middle is definitely, that thing is more stronger than a solid cylinder. So for a given mass, making a cavity will make it more stronger. It is more difficult to twist a cylinder with a cavity than a full cylinder. Clear with this? You can play like that. You can also ask you that ratio now. We know the k ka value is pi eta r2 power 4 minus r1 power 4 by 2l. And we also know the mass is constant, which is rho into pi r2 square minus r1 square into l is equal to constant. So for maxima minima, I can do dk by dr1 is equal to 0, isn't it? So you take r2 square from here and take it and dump it here, and then you can do maxima minima. So you will find a value where specific value of r1 and r2, which will give you maximum torsional constant. Clear with this? So you can play around like that. You can play with time period, you can play with that cavity stuff and everything. Meaning, if I had to give you one more model on this, you can think of, suppose if there is a cylinder, it is placed on another cylinder. This guy is fixed. This is R, this is 2R. This is stuck here, okay? You stuck it with a glue or something. Now, if I try to rotate this by theta, then if I ask you torque, what do you think will be the difference between this and that question? Just tell me what will be the difference. Then you can handle it. I will leave it to you. If I ask the same question, there are two cylinders of length L and L, R and 2R, they're stuck there. Bottom one is fixed. How much torque is required to rotate the upper cylinder by theta? What will change in this? They're in series. Series से क्या करोगे record? What is series? What is even series? Tell me one thing. When do you use the series parallel thing? When there is a flow, right? Flow of charge, flow of heat, flow of water, something flow. What is there? You're twisting here. कुछ भी मत चिपकाना. Don't stick anything to anything that you feel like. Anyone figure out what will change? Length from the bottom? Nah. See, what will change is this. You cannot apply the whole formula for the two cylinders. You have to apply for them separately. So let's say if this was point O and this was A, so this will be OA. You're saying this is theta, fair enough. So this is O, this will be B. The bottom floor also will rotate, na Abhi? You're getting it? This will rotate by some angle, some theta or alpha. You're getting? The line OB also will rotate. इसके नीचे O and C, that will not rotate. Making sense? So when you write eta for the upper one, इसके लिए equation ऐसा आएगा. Eta is equal to tension by area, that would be fine, and pi r square. What will be delta x here? Well, let me write the force part only. F tangential will be eta a dx by dt. dx यहाँ पे क्या लिखेंगे? dx will be r theta minus r alpha by l. Because it's a displacement between this and this ना, दोनों twist हो रहे हैं. समझ में आ रहा है? And from here you'll get the torque. When you do for this guy, F tangential, here it will be eta area, this would be R alpha by L. And यहाँ पे भी torque calculate करेंगे. And then we will say this torque is equal to this torque because it is in steady state. Are you clear with this? So when you take the displacement, it's a relative displacement between the upper layer and the bottom layer. In this case, even the bottom layer also will rotate. Are you clear with this? And because the single cylinder question is actually a pretty standard model. Maybe you guys have not seen this or you forgot, but this is not really that out of the world. So if they play with something like this, the next level will be either a cavity one that is also manageable. This would be a pretty good one. They'll put two double cylinders and they'll mess it up. So make sure to give it a try. Again, not that difficult, but it's a good one there. Clear? Next thing. That's a bit on rigidity modulus. Let's say we have a rod here. This is 2F. You're applying F, Young's modulus, area, length L, right? Find the elongation in the rod and the energy stored. Again, this is another standard model. Remember, tension will not be constant, so you can't use the formulas directly. You have to integrate. Let's see. Mass M. So I'm taking a uniform rod. I can mess up the density also. Let's see. Then the second question, I'll ask something like this. Then I will say force F, but this time the density will be lambda, not into 1 plus x by L. Just get me the equations and leave it. No need to integrate till the whole thing. Find the elongation and the energy stored in the rod. This is your linear density. Young's modulus by AL वो सब same ही है. Elongation is easy. Get the energy part. Listen to the general formula there. We know the formula, right? For this thing, Young's modulus is equal to tension length by A delta L. I'll write it as E for elongation. And for the energy stored, half stress into strain into volume, but I like to write this half stress square by Young's modulus into volume. Same thing. Strain, you write it as stress by, Young's modulus, and you'll get this. So these are the formulas for constant tension. If the tension in the rod is constant, use this formula and it works. Right? So just give me a minute. If your tension is changing, then how do you handle this? If your tension is changing, what we do in the rod, we'll take a small piece dx. So dx is the length of the rod. And then we will say this dx rod is having a small elongation de. Then your formula becomes de is equal to tension L ka place mein dx by a y. So elongation will be integral T dx by ay. What about the energy? Integral half stress is nothing but tension by area ka square by Young's modulus. Volume will be A into dx. Clear with this? So get the tension, substitute there, integrate, you're done. You'll get the answers. So you have to integrate for each section. Got the process? So the main question becomes finding the tension. Now, how do you find tension in both the cases? So this is 2F, this is F. Acceleration will be F by M. You want to find tension here, cut it there. Wherever you want to find tension, assume you just cut it there. Take any one piece, the right or the left one, doesn't matter. So this is 2F, this is tension, and this is your acceleration. The mass of this small piece will be M by L into X. Therefore, you'll get 2F minus T is equal to small m into A. So यहाँ से tension आ जाएगा 2F minus T, that is F by A. How much is this? 2F minus T is equal to M by L X and F by M. F into 2 minus X by L. That's your tension. Substitute in these two formulas, integrate, you'll get the answers. Clear with this? Right, at a mains level, if they ask you this question, right, if you have 2F and F, what you can take F average 3F by 2 and finish it off because it's a linear function. ये भी हमने class में किया था, but it won't work for energy because energy, if you see, it's a square function. So be careful, it doesn't work for that. Maybe CET में चलता है, but advanced में you will get slaughtered. What about the second part? And this is not the actual question. Next question, actual question is coming next. This thing is just starters. I'm just getting you used to this main formula there. You need, but this is still important, that integrating and stuff. It's still a good standard model though. Yeah, but F average is only for elongation. Can't use for energy. So इसमें क्या करेंगे? Same thing, acceleration. So first you need to find the mass of the body, which is integral lambda naught 1 plus x by L dx from 0 to L. Once you get this, you'll get acceleration is equal to F by M. Story is the same. You want to find tension here, cut it there at a distance x. Then draw the FBD of that small piece. We get F, we get tension, and we get acceleration. This will be F minus tension is equal to mass into acceleration. But what is the mass? Integral lambda naught 1 plus x by L dx. Limits will go from 0 to x. Yeah, so tension aa jayega. Once you got the tension, put it in this, you'll get the answers. But you're getting the idea there. So these are the standard formulas. Matlab, for everything, this is the thing. You just need to get the tension and dump it there. So the whole question, right, becomes mostly NLM question. It is about finding tension. So that is one thing in elasticity. Half of the questions are based on tension. If you can find tension, things will fall in place. All clear with this? So what I want to ask you was this. So, but yeah, that derivation was important. What if you have a rod where you're applying a force F and you're pushing with force F, Y, A, L, and initially the rod was uniform. Find the elongation, find the energy stored, find the shift in center of mass. If the rod is getting compressed, right, so the density of the rod will change. Density won't be uniform. Think about this. If you have different tensions, you have different elongations and different compressions. That means each part of the rod got compressed and elongated by different amounts. That means each part of the rod, the density has changed. So the rod has become non-uniform. So the center of mass will not be in the center anymore. So initially center of mass is in the middle. Now how much will the center of mass shift? So I'll ask you those questions. Find the new density of the rod as function of x. Find the center of mass of the rod and so on. So first two are manageable. You can handle it. How do you do the third part? Let's see. This is a pretty interesting one. How much you got elongation? You get 0. If you look at this rod cut tension, right? Acceleration is 2f by m. If you cut it somewhere here at a distance x, we get f minus t is equal to mass will be mx by L into 2f by m. So we get tension will be f into 1 minus 2x by L. So if you actually look at this tension versus x graph, you will notice the graph looks something like this. So this part of the rod, the tension is pulling, this is actually elongating. The front part of the rod elongates. The back part of the rod is getting compressed. So when you look at this rod, the front part of the rod is being stretched. The back part of the rod is being compressed by the same amount. So the change in length of the rod is 0. But does that mean the rod is not under stress? Rod is under stress. You're getting it exactly at the midpoint, the tension is 0. So the right side, this is a compressive tension. Think of like this. You're standing here. One friend catches your hand and pulls you, and another friend pushes you from the back. Your back part of the body is getting compressed and the front part of the body is getting stretched. This is a compressive stress. This is a elongative stress. So for energy, what will you do? Energy you have to do, you can just put it in the formula, it will work, you'll get it. Or you can do from 0 to L by 2 and double it. Either way it works. But if you do for the elongation, you'll get 0. Clear with this? So in this case, the net elongation is 0. So the length of the rod does not change. And for energy, you can dump it in that formula. But how do you find the shift of center of mass? If the back part is compressing and the front part is expanding, how do you figure out the center of mass? And remember, the rod is non-uniform, so you can't do this. You can't say ये part का center of mass यहीं पे होगा, ये part का center of mass यहीं पे होगा. I'll find the center of mass of these two. That would be wrong because those rods are not uniform rods anymore. How will we get that? So for energy, you can simply do half T by A whole square by Y ADX. That will give you the energy part. What remains constant? Mass. So at a distance x, if you take the small slice dx, so when you apply the tension, what happened to the small slice dx? This thing got stretched by dE. Let the density be lambda, let the density be lambda dash. So the mass of this small piece will be lambda into dx. This must be equal to lambda dash into dx plus dE. Does that make sense? Because mass of the small piece should not change. So we are assuming that dx got stretched by dE. But what is dE? We already know that. dE is nothing but tension dx by ay. Take it, dump it here. This will be dx. This will be lambda dash. Take out dx common. You'll end up with 1 plus t by ay. Dx will cancel. Lambda dash. Lambda by 1 plus tension. But what is tension? That we already know from here. F into 1 minus 2x by L by ay. That's your new density as function of x. How do you find center of mass? So the new center of mass will be integral lambda dash dx. That's your dm into x by integral lambda dash dx. 0 to L, 0 to L. That's because the length didn't change. That's how you find the center of mass, isn't it? So now your new dm will be lambda dash dx. Clear with this? So once you get your new density, you can finish out the center of mass. So this is the density, new density of the rod as function of x. This is how they can play with it. You can bring elasticity, compare that with the density, and density is the center of mass. Clear with this? So questions can be sorted this way. It's a good one. The main idea is this thing, like, that you can do this part to get the density is the catch. Once you got that, then things will fall in place. So there, now you got an idea there. Let's see one more. We have a hemispherical bowl. Filled with water. Radius r, and we have a small hole. Area A. Water starts leaking. Find the time when the tank becomes empty. You guys know the result for a cylindrical tank? वो standard result था. Root x is equal to root h minus a by a root over g by 2 time. This is the thing for a cylindrical tank. Or a uniform, area of cross section for a tank. This is the result. You should know these things. Exam, you won't have time to derive for standard stuff. But this thing will change the shape. It's a hemispherical bowl. Find the time taken to empty the tank. Now, if you don't know the derivation for that, then you'll find it difficult, this thing. So derivations are important for advanced perspective. You should know how you're deriving each and everything. Let's get this. So in case you're wondering what is the derivation there, fluid mechanics, we did this thing in, yeah, this is the derivation. So page 128, fluid mechanics. So you should check it out. I think we did it for different shapes also, I guess. That किया था notes में, but we didn't finish all the derivation. Then we did for some other shape. This is a different question. Should check out this stuff. क्या था page number? Page 128. That will be a mains and bits ka direct question, that is. Find the time taken when the tank becomes empty. Get this? I'll give you a minute or two. Get me till the integration, then you can leave it like, I know you can handle after that. It's a little lengthy, but not a difficult integration though. How do we start all these things? After time t, always you start from time t. After time t, let the height be some y. And in time dt, let dy liquid come out. Dy height decrease. Now, the derivation is important because tomorrow they will say there's a new shape like this. Y is equal to x square. So the idea is always the same. So let the liquid be till this thing here. So in small time dt, let this much liquid escape out. This will be dv. So if you look at this, this will be actually a thin disk of radius x, and this is dy. So this will be r minus y, and this will be y, and this will be x. Sorry, that's r. I think let's do one thing. Let's take this only as y. Y का limits change करेंगे, वो better है. So then we know x square plus y square is equal to r square. Perfect. So in dt time, this much liquid flowed out. So volume flow per second is area into velocity. Remember, what is the velocity here? Root over 2g. यहाँ पे problem आएगा r minus y. Because when you take the height, this should be the height. Let me see. Whichever will look good, we will see. So the liquid that flowed out will be a into v into dt. That is a into root over 2g r minus y dt. But volume flowed out is also a minus pi x square dy. Why minus? Because it is decreasing. A into 2 into, I think a better. Let's take this only as y and r minus y. We don't want to deal with the root memo that time. Into dt. There, you're done. So this will be pi, and what will be this thing here? R minus y whole square plus x square is equal to r square. So this will be pi, x square replace karo, which will be r square minus of r minus y whole square into dy by a into root 2gy is equal to dt. You can integrate that, right? That is x power n ka integration. It looks big, but it's pretty solvable. R square will cancel. You'll end up with 2ry plus y square by root 2 gy. So you'll get r power 3 by 2 and r power 5 by 2 का दो terms आएगा. Put the limits from 0 to r and 0 to t, you'll be done. Clear with this? So I will leave this much you can integrate. So this will go from 0 to t. Y का value क्या होगा? This will go from r to 0. Because initially y was r and finally it was 0. All clear with this? So if I change the shape, it will be different things. So that is one way you can play around with this. Next thing. This is another important one. Let's see if you remember this. You should definitely check out the surface tension notes. Huh? We did a lot of different models. The eyedropper, right? A bubble entering the container. We had different stuff. Where are you? Where? This one. This we did in the notes, but it's a pretty good one. So we have a capillary tube of radius r on one side. So this is your capillary on the left-hand side, and this is a big pipe. So you can neglect capillary action here. Read the question. So as you pour the liquid, this would be, let's say, H1. This will be H2. So you're pouring liquid drop by drop. So the question is plot H1 and H2 versus time graph. This is a capillary. So on the left-hand side, surface tension will be there. On the right-hand side, the pipe is so thick, you can ignore the surface tension. Now you started pouring into the container drop by drop. So how will the height of the liquid level on both the sides change? Plot the graph H1 and H2 versus time. Give it a try. I'll give you 3-4 minutes. It's a big one, but it is a really good question. It teaches you about the capillary, about everything about the capillary action. Anyone not clear with the question, please ask. So that's all the data that you have. So in case you didn't figure out what happened, just to give an idea, initially when the water falls, the surface tension will pull all the water inside, isn't it? Up to what height? H is equal to 2s cos theta by rho gr. Yeah, height of a capillary action. So until unless you reach that much height, the water on the right side will not be there only. The water will just keep going into the capillary. Then after that point, then the water will start rising on both the sides. So first try to understand the whole scenario, what happens, and then try to put it on a graph. we did this thing in surface tension. Look at the scenario here. Have a look at this page. This is what will happen. This is a full cycle there. So look at the first picture here. In the first picture, when you keep the liquid, all the liquid goes into the capillary. So there'll be no liquid on the right hand side. Jo bhi liquid aa raha hai, it will just keep rising in the capillary. Then look at the second picture. So as you keep putting more and more liquid, you will reach a height of 2s cos theta by rho gr. So till that point, there'll be no liquid on the right hand side. All the liquid will go to the capillary. Picture 3. At this point, now whatever liquid you're pouring, because of fluid mechanics ka pressure, ये दोनों का height same होगा. But capillary में you'll get an extra height 2s cos theta by rho gr. You're getting? If you had neglected capillary action, both the containers would have same height, isn't it? If you think about it, without surface tension, the height of the liquid level will be same in a U shape, independent of area of cross section. So now what will happen? Both the sides height will increase, but the difference will remain same. Both will increase at the same thing. Next thing, fourth picture, look at this picture. Once you reach the top, now something weird happens. Once you reach the top, the water, right, cannot come out immediately. It actually forms like a bubble. Because if the water is trying to come out, the same surface tension which is pulling you up will start pushing you back. Meaning, think of like this. Suppose, if you take a needle and prick your finger, will you get a fountain? You don't get a fountain, right? You get a blood drop like this, isn't it? I know some graphical images, but yeah, you can see this. सिर्फ Tom and Jerry में fountain आता है ना? In Tom and Jerry, when you hit the Tom gets a fountain of blood. In reality, it doesn't happen like that. The surface tension will not let the blood flow. You'll actually get a drop like this. So something similar happens here. On this top here, the droplet, right, it forms like a bubble. The same surface tension will stop you from going out. And this will happen till when? Look at this thing here. So if the bubble forms outside, this pressure is P naught. यहाँ पे pressure होगा P naught plus 2s by r. So this time, the height on the right-hand side will increase. It will go beyond the pipe up to h dash. So when this pressure rho g h dash becomes equal to the excess pressure 2s by r, then the bubble will pop. And then the liquid starts coming out. At this point, heights will become constant. Are you getting the whole scenario? This is what happens with the whole picture there. Can I just go through the 6 pictures once? Take a minute. Understand them each and everything. I'll number them for you. 1, 2, 3, 4, 5, and 6. This would be a good paragraph if at all I ask you. And drawing the graphs, graph is a pretty good one. How do you think the graph will be? Can you draw the graph? I'll give you a minute now. I told you what will happen. Can you put a graph? Got it. Let's see how the graph would look. This you should check it out. This is a little big question. Like that's why I said it is worthy of a paragraph. They can't ask this thing in a single choice. If they ask you, you are dead basically. takes a bit of a time to figure out what the hell is happening. Look at the graph. Let me show it to you step by step. First, look at the red line. Okay, red line is the left-hand container H1. So initially, the red line is increasing. Right. Look at the green line. Green line is the right-hand side. The height, right-hand side height is not increasing. It is zero. So that is the first part. Then what happens? Once you reach the topmost point, this guy, the height on both the sides, can you see both the lines are parallel? The difference between them will remain constant. This is what I was saying. Both will increase at the same rate, but if you observe something here, observe किया ये line का slope change हो गया. Why? Because initially all the water was going only into the left hand side. Now the water is going left and right, isn't it? तो share हो रहा है. So the height will not increase as fast as before. It will increase, but at a slower rate. And at this point, liquid has reached the topmost position. So its height constant हो गया. This cannot change anymore. But on the right hand side, the water level will just keep on increasing, increasing, increasing. At this point, the bubble will pop and the water starts leaking. This is how the graph will look with the slopes changing a bit. Clear with this? That's what makes this question a really good one. So there's a lot to analyze. Like there's a surface tension, there's a fluid mechanics, and you have to keep thinking about, oh, is the volume flow same or not? Clear with this? Take a 5 minute break. Come back in 5 minutes. We'll continue again at 9:47. Any doubts so far? Come back in 5 minutes. So let's say we have a liquid here, and let this radius be r. So the liquid level rises here to a height h. So this is r, the surface tension between the liquid and container is S. Then what you did, then you brought a solid rod. So you took a solid cylinder and you placed it along the coaxial line. You just placed it in the middle. So इसका radius is r by 2. Along the coaxial axis. And इसका surface tension is 2s. So 2s is the surface tension between the solid rod and the liquid. Now when you introduce this, the liquid will rise to a new height. Find h dash in terms of h. So initially when you keep a surface capillary, the height goes to h. That is given. Now the same capillary, if you introduce a rod in the middle, it will rise to a new height h dash. Find h dash in terms of h. The liquid gets land from the rod to the container. We are neglecting that edge guy effect, so don't worry about it. Normally, I know what you're trying to say. ऐसा कुछ हो जाएगा ना? We will generally ignore this meniscus, okay? Meaning इतना exaggerated नहीं होगा वो. You need to understand when you draw this meniscus, right? If you remember in the capillary, we always take the height from this point, isn't it? We used to ignore this part of the liquid, right? So वो ignore कर लेंगे, so it's fine. In the figure, I'm drawing it too big actually, but these are very thin. So 4h by 3, 8h by 3. Okay, how do we do this? It is simple, just an FBD you have to draw. So here initially what was the surface tension? I didn't give the contact angle. Okay, you can take contact angle as 0 or theta, whatever it is. So if you take the surface tension here, we'll take theta as 0. इसका भी theta 0 ले लेते हैं. I can give different values, but ठीक है. So this will be 2 pi rs cos theta is equal to, this will be mg, which is rho pi r square h into g. So this is 1h. So here there will be two surface tensions. This is pulling up. This is also pulling up. So the net force will be 2 pi rs plus 2 pi r by 2 into 2s is equal to density. What will be the area of cross section now? Pi r square minus pi r square by 4 into h dash into g. Make sense? So when you take the area, don't take the full area. You should take the balance area, isn't it? You should take this area. Because the solid cylinder will not let any water there. बस इतना ही करना था. Take 2 pi rs and substitute there and you'll get the answer from here. You take 2 pi rs, substitute and you're done. Easy? Yeah, so check kar lo. I think people are saying answer is 8h by 3. You can check your calculations. Anyway, that's still an easy one though. Next one. We got a fixed cylinder. In the middle, you introduced a rod. This is R and this is 2R. And the space between them you filled with a liquid, viscosity eta. And then you started rotating the cylinder with a constant omega. You're getting how it is? We have a cylinder filled with liquid, you kept a rod inside and you're doing this. वो होता है ना, when they do buttermilk, याद है? They put a rod and they will just spin it. I don't know what they call it. To remove the butter, right? You do that thing. So it's something of that sort. You kept a rod in the middle of this thing and you're just rotating it with omega. So this whole liquid starts spinning. Find the torque required to maintain the omega naught. Because there's a viscosity, the rod will decelerate. So you have to apply some omega. Find torque on that inner cylinder to maintain omega. Find heat produced per second. Find omega as function of x. Different layers will have different omegas. Yeah, I can ask you a lot of things. Meaning, they could have done like this also. They can say the outer cylinder is rotating in the opposite way to omega naught. So you can do all that stuff. But I think let's get these three. Now, just to give an idea here, वो formula याद है dv by dx? You cannot write this thing as v2 minus v1 by z, x2 minus x1. The velocity gradient, you cannot write this anymore. This is valid only for thin layers. So some people, what they will do, they will say, okay, this is going with r omega naught, and this thing is going with 0. So they will write dv by dz is equal to r omega naught minus 0 by 2r minus r. This would be wrong. You cannot do that. That formula was valid for thin layers, and these are not thin. So be careful with that. Because in that question, right, if you remember when I taught you in electrostatics, Did I teach you in electrostatics? Or maybe rotation, I guess. This one. So here, if you see, na, specifically I mentioned thin viscous liquid. So if it, because it was thin, I could do this. I directly wrote R omega by dV by dz, which is R omega by z. So you can't do this if the layers are thick. In this scenario, it is not thick, thin. So if they don't, that is how they don't mention it. How do we handle this? This would be another good one. The length is L. So the system has reached steady state. Okay, this is in steady state. In steady state, find torque, find heat, find angular velocity. Let me ask you this question. What do you mean by steady state? You keep hearing this word steady state circuit a lot of time. What is steady state? The property at a point does not change with time. What is that property? In case of circuits, that property is voltage at the nodes, charge on the capacitors, current in the resistors, isn't it? These are the properties in a circuit. In a fluid, what are the properties? Pressure at a point, velocity at a point. In heat transfer, what is the steady state? Temperature at a point, heat flow through a point. These are constant, isn't it? So in this case, when you say it is steady state, means what? Every layer has different omega, but that omega is not changing with time. Making sense? Every layer has different omega, but the omega is not changing with time. If omega is not changing with time, that means what is alpha? Zero. For all the layers, there is no angular acceleration. That means for all the layers, the torque is same. Whatever torque is acting here, the same torque is acting on the other layer. You're getting it? So the differential, the torque is acting, the net torque on each layer is zero. That means on all the layers, you have the same viscous force ka torque. So take a thin cylinder at a distance x. So see, so at a distance x, take a very thin layer. Let's see. Each layer has different omega, but omega is constant. It does not change with time. So omega for a layer is constant. Therefore, alpha is equal to 0. That means if you just try to see this from the top view, क्या हो रहा है पता है? So the inner layer is giving you one torque and the outer layer is giving you another torque. Right? And both the torques are cancelling out. That's why the omega is constant. You have reached steady state. Clear? So there is an inside outside. There are two forces on both the sides. Now let's try to find the viscous force on this. Now we know F viscous is minus eta A dV by dz. But let's try to understand what is this dV by dz. Now see, when you're taking the layers here, what is happening with the layers here? For example, let's say this layer is going with omega, and let's say this layer is going with omega plus d omega. Let this distance be r, and let this distance be dr. So dv by the distance between them dr, that will be r plus dr omega plus d omega, that is the velocity of that layer, minus r omega by dr. R omega will cancel. Then you'll end up with r d omega plus dr omega dr d omega by dr. You'll actually get four terms, and we ignore this. We can't do this actually. Wait. We will actually assume the omega is almost same for the up and down actually. That then we will get r. So this now there is a formula for this. You can't derive from here actually. Then you end up with r omega. How much is this? Wait, I'm doing something goofed up. R d omega by dr. Hmm. Omega again. Hmm. R plus dr. Okay, let's try this only. D omega minus r omega by dr. What will I get? Dr omega dr d omega plus omega dr by dr. This term is negligible because it is small. You end up with omega plus omega. This is r d omega. This doesn't make sense anymore. Yeah, I think we need to use the other concept. Okay. I thought we can derive without telling you that. Now in fluids, right, there is a formula for this. So the strain, right, is not given by dV by dz. It is actually the strain for fluids. The shearing strain is given by there is a formula there, r d omega by dr. No, there is a formula like that. You will not know this. They will actually have to give you in the question only. Without that, you can't solve. ये actually Erido का question था. I modified a bit here and there. But okay, for now, I'll make it more simple. You can write dv as r d omega, and then you can write this dr, and you'll still end up with the same answer. Let's do that, and then I'll show you. So F viscous is this. I'm not happy doing that actually. Okay, I'll show you that bit. So in NCERT, right, there is a statement like that. For solids, the shearing strain is given by, the theta, which is delta x by d, which is almost equal to theta. So whenever you have a solid, and when this thing gets deformed, so we take this is delta x, this is d. So tan theta will be equal to delta x by d. For again, this is a very small theta, so this is t. But for liquids, the shearing strain is actually d theta by dt. It is the rate of change of shearing strain. So it is the rate of change of the shear angle is the shearing strain. This is experimentally determined. This is the rate of shear angle or d theta by dt. Now, they'll not expect you to know all this stuff, so I'll do one thing. I'll simply give you here for liquids, right? dV by dz is r d omega by dr. You can use this. So end of the day result will be that only. So that has to be given. So without that you won't get. So abhi ki question kya ho jayega? Eta area will be 2 pi x dx. So the dv by dz, you could have said this thing as x omega by this will be, sorry, this is 2 pi x L. This is dx. Clear with this? Here A is the surface area. dv by dz. So the dv by dz is your shearing strain, which is x d omega by d x dz is the thickness between the layers. This is the viscous force on one cylinder. So what is the torque on the cylinder? Torque on the cylinder will be x into F viscous. This will be minus eta 2 pi. Then you'll get x cube L d omega by dx. Now, like I said, the torque on each cylinder is constant, isn't it? Because you're applying a constant torque on the outer cylinder, that same torque is being transmitted to each and every layer, isn't it? So this torque is constant. This is the torque which you're applying from the external torque. This is same as the external torque. Because you're in steady state, the external torque must be equal to the viscous torque. So now when you write this, torque on the cylinder is minus eta 2 pi x cube L dx by d omega by dx. You're done basically. Bring everything to one side. Torque dx by x cube is equal to minus eta 2 pi L d omega. So you have to integrate it two times. What are the limits? This will go from outer cylinder, inside cylinder is going from omega to 0. This limits will go from r to 2r. Solve this, you'll get torque from here. Once you get the torque, dx by x cube, if you go from r to x minus eta 2 pi L d omega from omega to omega as function of x. If you integrate this, you'll get omega as a function of x. And what is the heat produced per second? Heat per second is the total power produced by the external force. Power is nothing but torque into omega. Clear with this. So you'll actually get as a 1 by x square function. All clear with the steps? So the main idea is this thing. This has to be given. They gave it in Nerido also. I thought I could do this without using it, but I think we need to use it. You couldn't derive this. So the formula is only different. For solids, it is a shearing angle. For a liquids, it is called rate of shear angle. So d theta by dt. So once you do that, I think then you will get it. So when you take the element omega plus d omega, and this is omega, this is r, and this is r plus dr. So this is your angle. So that would be r plus dr. Okay, anyway, let's not get into this. So you should know this thing. But is the idea clear, everyone? So the omegas will not be same at every layer. They will have different omegas. Go through this once. I know that thing, right? You should know that result dv by dx. Other than that, everything else is manageable. Let me ask you one more like this, but a little different one. यहाँ पे वो problem नहीं आएगा. Let's say we have a solid rod. This rod is moving with v, and this outer one is going with 2v. And the space between them is filled with a fluid. Find the force required to pull this cylinder out with a constant velocity. This is a long cylinder, okay? So length L. You can ignore this, these effects here. So we are just assuming you're just pulling it out. Radius is taken as r into r. Again, same idea here. Every layer will have different speeds, but that speed is not changing with time. So look at here. These layers are going backward and these layers are going forward. So beach mein, there are layers which are going like this, and after some time there are layers which are going like this. The liquid is flowing with different velocities there. So the main idea in all these questions, right? You cannot write dv by dz as v2 minus v1 by z2 minus z1. That's the main catch there. This will be given. Done. Let's see. So what we do, we'll take again a thin cylinder somewhere at a distance x. Let the velocity of this layer be v. So when you apply the viscous force on this, that would be eta. Area will be 2 pi x L dv by dz. So z is a distance, dv or dx. So again, the idea is the same thing here. So the viscous force, right? If you see on each layer, the velocity of each layer does not change with time. All right. So yeah, therefore that means this, therefore acceleration is zero. And therefore that external force which you are applying must be equal to F viscous. That means this is a constant. So you have same viscous force on every cylinder. Making sense? They have different areas and different velocities, but all have same amount of force on them. So then we will get a dv is equal to eta 2 pi L dv is equal to this F viscous, which is F into dx by x. So what are the limits going from here? So limits will go from r to 2r. Velocity will go from v to minus 2v. Right? So when you solve this, you'll get Fk value from here. And then once you got Fk value, you can even find velocity as function of x. Clear with this? So in all these questions, that is a main theme there. That friction or viscous force or the torque will always remain same. Clear with this? So that is one thing. So there, these are the two questions based on that. When you have this cylinder rotating, this is a much better one. But like I said, this has to be given. Without this, you can't solve. So the whole concept changes there. But yeah, the main idea is that. Let's see one more. This we did in the notes. Let's see whether you remember this. Or let's do this one. This is an easy one. Let's see whether you remember this. No, let's do the other one only. So we have a container with a hole. What you did, you brought a solid cylinder and you blocked the hole with a solid cylinder like this. You're getting what we did? So there is a hole here. So you kept a solid cylinder inside and you got it stuck. The radius of this hole is r. This is 2r. This height is r. This height is also r. Density of this solid cylinder is, solid cone. Solid cone. The density is rho by 3. Now what you did, you started pouring liquid inside of density rho. So as the liquid starts coming in, at some point, the cone comes out of the hole. So find h when the cone comes out of the hole. Solid cone blocking the hole. Atmosphere pressure is P naught. Questions here? We can do even better. Wait. Let's put the liquid till here. Actually, you'll get two heights when this can come out. One below this and one till here. Now what? Density of the liquid is rho. Hmm. Yeah, better. Let this be h. So from this surface to this, the same thing, doesn't matter. Get this. So we have a solid cone of one third of the density, which is blocking that hole of radius r. As you keep pouring liquid, it is observed at this particular height, it comes out of the cone. Find h. Finish off. Last one for the day. People are tired today. Can you apply bind force here? That is the first thing. Bind force is not applicable. Now, let's see how will you handle this. Just get me the main equations. We got the equations, you are done this. If you draw the FBD, you will see something. Okay, now if you draw the FBD, right, you will see this thing for the cone. So from the top, we have P naught plus rho GH 4 pi r square. This is the liquid which is pushing from the top. And from the sides, the liquid is pushing till this point here. And I don't know how much is this. So, but this will be, let's call it F side. At this point, you have the hole there. And from here, atmosphere is pushing P naught. This pressure is constant. So I can just use the projected area, which is P naught into pi r square. So if your pressure is constant, you can simply take the projected area. Now, why can't I do with the F side? Because the pressure is not constant. And you also have your weight mg. Bus. And because you're touching the cone here, there is also a normal reaction N. So the normal reaction N will be mg plus P naught plus rho GH 4 pi r square minus P naught pi r square minus F side. So this is the normal reaction between the cone and the container. Now, since you're saying you're going to lose contact, N will be 0. So now in this equation, if you see the only guy you don't know, you need to find H here. Mg I know, this I know. What I don't know is F side, isn't it? So if I can find F side, my job is done. How do I find F side? So there's a very beautiful trick there. So you should know that thing. That is the main idea of this question. If you can't use buoyancy force, but if you use something like this, some weird shape, how do you handle this? There was a question like this in advance. उसमें question ये था, I don't remember which year, there was a stone here. This surface was flat and there was another stone here. Both the stones got stuck. This density is rho, this density is 2 rho, something like that. And the density of the liquid is 3 rho by 2. This volume is V and this volume is V. So technically speaking, average density kitna tha? 3 rho by 2. So the body will have, buoyant force will be equal to mg. And then it is mentioned, these stones are thrown into the water, thrown into this liquid, and as they start going inside, there is some glue here. So the maximum force the glue can withstand is they gave you some number. Maximum force when glue breaks is some 100 Newton kuch to diya tha. The question was this, at what depth both the stones will separate? When will the glue break basically? So there was a question like this in JEE. I don't remember which year. You can check it. It's a pretty good one. So the problem ये था, मतलब if you think about this thing, right, you can't apply buoyancy force on each one separately. This thing ka weight is less. This thing ka weight is heavy. This guy wants to sink. This guy wants to float. That means in the middle you're having a stress, isn't it? So that is the thing which is trying to break the glue. So there was a question like this. So what was the idea here? Listen to this. Agreed, you can't apply the buoyant force, but imagine we have a cylinder till only this part of the cylinder. I'm just taking the top part of the shape. Again, this has nothing to do with the previous question. I'm just trying to show you something. And let's say this whole thing is filled with liquid. Now can I apply buoyant force? Now this whole thing is filled with liquid. Now buoyant force is applicable. So the force from the top, right, that would be P naught plus rho GH 4 pi r square. This is the force from the side walls, that is F side. And the force from the bottom, that will be P naught plus rho g h plus r into pi r square. Do you agree with these forces? This will be all the forces on the surface. But all these forces, if you actually calculate, how much is this? F side plus P naught rho g h plus r pi r square minus, I'll do one thing, wait, I'll just simply call this thing as F top, I'll call this thing as F bottom. So then I can simply write this thing as F side plus F bottom minus F top. Can I say this whole thing is nothing but bind force? Do you guys remember what is buoyancy actually? Buoyancy force is nothing but the difference in pressure between the lower and the upper surfaces. That force is what we call as buoyant force. Buoyant force is not some new kind of force. When you immerse a body in a liquid, at the bottom points the pressure is more, at the top the pressure is less. The difference in pressure creates an upward push. That only is what we call as buoyancy force. And that is the reason whenever you use buoyancy force, you should not use pressure in the FBD. If you use pressure, you should not use buoyant force in the FBD. They both are not two different things. They're one and the same thing. They're just, we are using in different language. Are you clear with this? So do I know F top? Do I know F bottom? F side aa gaya na? Are you getting the logic there? Now you tell me, like, I agree, it is not completely immersed, but does the liquid care about this side, whether the bottom is closed or open? Does the side ka liquid care? What is the shape? No, right? So F side will still remain same. Are you getting the logic here? So if the bottom part is not exposed to the liquid, agreed, you can't apply bind force, but you can make an argument. If the bottom part was liquid was there, so the bind force minus that force must be the remaining force, isn't it? Is that logic making sense? So the same way you can argue for this question also. So ये question में क्या होगा पता है? When I take this surface, you have your mg, which is rho vg. The liquid is actually, if this had been completely immersed in a liquid, so this is pushing down F1 and this is pushing up how much? Rho g h into that area. So rho g h into area minus F1 is your F bind force. So F1 is nothing but rho g h into area minus FB1. So this is your F1. Make sense? And बीच में जो है ये normal reaction था. That will be the tension between them. Are you clear with this? So you can actually find the force on this curved surface, even though you don't know what is that surface. But इसमें एक problem था. This should be flat. If that is not flat, then you cannot make this rho g h into pi r square. इतना easily नहीं आएगा. Is this making sense, everyone? So that is how you find F side. Assume the upper part is completely immersed in the liquid. The difference in force, the top, the bottom, the side, the three combined is called bind force. You know bottom, you know top, side aa jayega bhai se. Put it there and you're done. So no integration, nothing. That is how you can find the force on the side walls without integration. And this method will work only when you have flat surfaces at the top and bottom. Unfortunately, if someone comes and gives you a shape like this, and like this, you're gone. You can't find top, you can't find bottom. So then we'll have an issue there. But clear with this question? So this is one good one. You should definitely check this out again, right? Try to do this thing. So today's class, if you see, right, this is one good one. This cylinder thing is a very good one. Yeah, but that has to be given. This was also good. A lot of things. Yeah, most of them are good. This was something new. The shift in center of mass was something completely new. You'll not find that in the notes. This is also a good one, but this we did in the notes, but I extended it. So make sure to go through the whole thing. Right, Friday when we catch up, we will do EMI and AC. Again, I'm telling you, AC, please make sure to go through the recording and go through the notes. We used something called complex numbers. It was completely different. You will must not have done that way. So, and if you come to the class, I'm going to do with that method and you will have a problem. So just revise that. It won't take more than 40 minutes. So and it'll help you for your mains also. So just do it. It makes your life really easy. Questions become pretty fast. Okay, with that, we'll wrap up for that day. So, any doubts in the class notes, you can stay back and ask, or else you're free to leave. I'll see you on Friday at